Hello friends, welcome back. We have seen the first step of digital communication is to convert the continuous time domain into discrete time domain through sampling, and we have a particular instance T1, T2, T3, T4 where the input signal is sampled, and later these samples at this instance are found out, and then the range of the input is divided into some number of sub-intervals, and this is done through quantization because the magnitude axis is also continuous in domain. That means it can also have infinite possibilities, so we can't work with any infinite possibilities. So through quantization, these infinite possibilities are converted into finite. So in this case, the total range from minimum to maximum is divided into 4 sub-ranges, and each sub-range is given a code as 0, 1, 2, and 3. So depending on the instant when it is sampled and the magnitude of the signal at that instant, and in which range or sub-range that value is, the appropriate code is used for encoding. So in this case, the first instant is at T0, the first sample is at T0, and at T0 whatever magnitude we have falls in the range of code 0. So we say for range at T1 it is 0, at T2 if you look at it, it falls in this range whose code is 2, at T3 it falls in this range, therefore its value is 1, and finally at T4 its value is 3 because it falls in this range. So these are the codes. So 0, 1, 2 and 3 are the sub levels in which this magnitude domain can be divided into, and when it comes to storing this information, so we need to say 0, 1, 2 and 3, and usually we try to store this on a digital device, and digital device, as you know, works in a binary system. Therefore we need for encoding 4 different values, we need a 2-bit coding. So we have a 2-bit coding. So at T1 we want a 0, so that can be represented by a 0, 0. At T1, at T2 it will be 2. 2 means in binary it is 1, 0, and at T3 it is 1. 1 means it is 0, 1, and finally at T4 it is 3. 3 means in binary it is 1, 1. So this way the data is written onto a computer memory, and this is used for future analysis. So overall what's happening is the signal is continuous in time domain, so that is converted into discrete through sampling. The magnitude is continuous, so that is discretized using quantization, and then at every sample the magnitude, the quantized value is used, and that is encoded into appropriate version. So here we are using a binary code for each one, and this type of coding is what we call pulse code modulation. So here each one is given a value, and that value is written in binary, and that's a encoding process in the digital communication series. Thank you.